What's this? Creaform? What the? It's here. You knew it was coming. Last year, Creaform introduced the new HandyScan Black 3D scanner to unbelievable success. And that can only mean one thing, and that is the new MetraSCAN Black 3D scanning and probing system. And what we're going to do today in this video is we're going to walk you through all the new specs of this system. We're going to show you how it works, and then we're going to scan a variety of parts and see how it does. All right, so let's get started and talk about the specs of the new MetraSCAN Black 3D scanning and probing system. And we'll compare that to the old MetraSCAN 750. There's now a Black and a Black Elite, similar to the HandyScan model lineup. Now, this new scanner can capture up to 1.8 million points per second. Compared to the old 750, it could capture 480,000. So you've got a 4x increase in the capture rate, or the data capture rate. It has a capture volume, the area can see, of about 12 by 14 inches. So it's capturing a huge area, and now it is using 30 laser lines versus 14 in the old. So it's just gathering a ton of data quickly. Also has the single line mode like the old system had. In the Elite model, you get the single line system with it. Now, the resolution, or the density of the mesh, we can now go down to 0.1 millimeter like the HandyScan Black does. The old MetraSCAN could do 0.2 millimeter. So we've doubled the resolution, or the fidelity we can capture, so we can really get into that fine detail. Now, Creaform is an ISO 17025 accredited lab. And we've got some new standards that these systems are adhering to. Starting with the scan head, it is now certified under the VDI VDE 2634 Part 3 standard. Now, what does that mean? Basically, that is a standard adopted. It's a German standard that's been adopted by most of the non-contact 3D scanning companies, especially the structured light system. And it's a whole bunch of bars in a big volume area, and they're scanned from all different directions, and they look at the distance and the roundness of the spheres, and it's a whole standard they go through. And within that standard, the new MetraSCAN system is accurate within 25 microns. So that's the accuracy in kind of a local area. And the volumetric accuracy is 78 microns. So let me explain that a little more. So the accuracy given in a 2 or 3 or 4 foot range, you should expect about 25 microns, or about a thousandth of an inch. And in the whole volume of the C-track, which is 16 meters that it can see, everything should be within 78 microns, or 3 thousandths of an inch. Now, we've done some of our own real-world accuracy tests, and we typically see numbers even better than that. So stay tuned for that test, and we'll see how this new MetraSCAN system performs. But at least the published numbers are 25 micron accuracy and 78 micron volumetric accuracy. Now let's talk about the probe. Probe falls under a different standard, usually done for CMMs and other any kind of contact measuring probing system, and that's the ISO 10360-12 standard, and it's pretty much the same specs. Accuracy within 25 microns, volumetric accuracy within 78 microns, and again in that big 16 meter volume. So again, very, very accurate. And now you don't have to worry. In the old days, probes or anything that contacted would be more accurate than non-contact like the scanner. And that's just not the case anymore. So now you can pick which tool you want to do. Do you want to do probing or scanning? And we've got a great video that kind of talks about when probing makes sense and when scanning makes sense. So I'd invite you to check that out. But at least now accuracy isn't part of that decision-making process. You would base it on other things. So both systems equally accurate. So it's just very, very impressive. So again, just to summarize, we've got 30 laser lines, blue laser technology, 1.8 million points per second down to 0.1 millimeter resolution, ISO 17 accredited lab with an accuracy of 25 microns in a local area and 78 in the whole volume. And same thing for the probe, same accuracy. So just absolutely impressive new system from Creaform. So let's take a look at the MetraSCAN system and explain how it works. Now there's a few different components, starting here with the C-track. And basically the C-track is a camera system. You've got some infrared lights that get emitted here, and then you have a sensor on each side. And basically what that does is it spatially tracks the scan head or the probe. So in this case on the scan head, you see all of these retroreflective targets. Those infrared lights are trying to light those up, and the cameras are trying to find it. And as long as the cameras can see at least 4 of these targets, it can track it in space. Now, more is always better, and that's why you see kind of this thing surrounded by all these targets. And the idea is no matter which way I'm holding it, the system can see enough targets to track it. Now, the only time this isn't going to work is if the camera being there and I block it with my body, it'll just stop scanning. So you don't really lose anything. It'll just stop tracking it and stop scanning. But you kind of get used to just holding it like this, and you can work it around any way and 3D scan. Now on the scan head itself, we also have 2 more sensors, and we have the laser light source right here. So the lasers are emitted out, and these sensors on board the scanner are picking up the distortion of those laser lines, and that's how it's picking up the 3D shape, and that's sending that data back to the laptop in this case, sending the scan data back to the laptop. So, and then for the probe, it's pretty similar. You've got targets on here in the front, and same thing, you would hold it in a way that the C-track can see the targets, and we've got some buttons on here to collect points. So you can hold it like this, or you can hold it like this, and pick up those points by pushing these buttons. This uses standard Renishaw components, and they're hot swappable, which is really nice. So you can put maybe different size or extensions and swap those back and forth, or maybe an angle adapter, depending on what you're doing, and you can do that back and forth without having to calibrate the system. Now, lastly, the C-track here, you see we're on what's called the shop floor stand, and this is great if you're out doing shop floor inspection or metrology, or even just 3D scanning. It's got a nice heavy base. It retracts up and down. Our controller can get stored on here. Nice big wheels on it. And with the battery power, you can run up to 2 hours without having to plug it in. But it just keeps all the cables and the controller nicely managed on it. And it just makes it real easy if you're moving around on your shop floor, to get some work done. So next, we're going to actually do some scanning on some different stuff, and we'll show you how that works. So we're set up here to do some 3D scanning, and we have a truck grill here, so kind of a medium-sized part, and we're going to go through and actually do some scanning. Now, you've heard me talk about the volume, the 16-meter volume. What is that exactly? Well, that volume, just to give you an idea, if you look here on the computer screen and I move the scan head around, you get an idea of how big this volume is. It's like the size of a small car. So that's a huge working volume that we can work in without having to move anything, or have a part that's pretty good size. So let's get started on the scanning. We'll talk more about this. So I push the button down on the front of the scanner, and I pull the trigger, and off it goes. And you can see with those 30 laser lines just how fast this is. Now, the other nice thing is, being a completely handheld system, I just keep moving back and forth, and I articulate my arm up and down, and you can see how quickly I can get around this part. Because scanners like to be perpendicular to the surface they're scanning. So again, by having the ability to hold this in my hand, in a variety of different ways, allows me to get down and get on different angles and around the part, quite easily, okay? And I hold it about 10 inches away from the surface. I don't have to be perfect, but I get a couple different readouts. One, on the part itself, if I get too close, it turns red, green is good, and too far away is blue. So as long as I hold it in there, in that depth of field, and then I've also got the same color readouts on the scan head itself. So if I can't see the computer screen, I can just look right on the scanner. You don't have to be perfect. It's a pretty good, size depth of field, and you kind of just get used to where you need to be. Now we also have the single line mode. That lets us get down into small holes, cracks, little valleys. What it does is it focuses one single laser line perpendicular to the sensors, and then they just focus in on that. And that's great to get down in some of this detail. And you can switch back and forth at any time you want. And you can't overscan the part. You can keep going over and over and over until you get pretty much everything you want. But you get an idea. Let's come out here and just scan the rest of this table. And you get an idea of how fast this really is. It's quite incredible. Okay, so let's stop scanning for a second. And we're going to talk about this mode we're in. And this system has two modes. So we've got the C-track just off the camera there, and we're running in what's called static mode. Okay? What that means is nothing can move. So the C-track itself can't move, and the part cannot move. And that's the pretty standard or typical setup of most CMMs, most articulating arms, most structured light systems that sit on a tripod. They can't move around. So on an arm-based system, you've got a big heavy-duty base usually, or a big granite table, and you've got the part fixtured down. CMM obviously is a big granite table and everything is fixtured. Same with a structured light system. While it's taking a scan, it cannot be moving, and the part can't be moving. Well, the problem with that is, a lot of people are wanting to go out on the shop floor and do this stuff because it makes a lot of sense. Go to the part instead of having to take the part somewhere else. Well, what's out on the shop floor? You might have a stamping press or injection molding or some other assembly equipment. You've got high-lows and forklifts and people walking around. Somebody comes up and bumps the table, and the problem you have is now you've lost your accuracy, because if anything moves, your accuracy goes out the window. So let me show you exactly what I mean. Okay, so let's go back into scan mode here, and let's go back to scanning. So you can see, now we'll exaggerate this, okay, and I'm going to move the part, but you can see what's happened, okay? So now we've got, basically a big mess, okay? So that's obviously maybe exaggerating a little bit, but, small bumps and movements, if you're trying to hold a tight accuracy or get a good quality scan, you're going to have problems. Now, there are times we use static mode because it just makes sense. We're not out in that harsh environment. Maybe we've got it's a smaller part, and it's just easy to scan it, flip it over, scan it again, and align the data. So, there are times that static mode is good. But we have another mode, which we use probably 80% of the time, and that's called dynamic referencing. So we're going to get that, we're going to set up for that and show you how that works. All right, so now let's talk about dynamic referencing. And what is that? Well, it's a way of referencing the part while you're scanning. So what we've done is we've put some targets on the part, and you only need technically 4 of them, but you typically want more because if you were blocking a few of these while you're scanning, it would not be able to scan. Because basically what's going on is the C-track is now tracking these targets, which are 12mm targets, while the scan head is 10mm targets. So it can differentiate between the two. So again, you just put them on the part. The sticky ones work great. We also have magnetic ones. We have swivel ones. So you can pick the right target for your application. And you just put them random on the part. And then you come over here in the software and you tell it, and I'm going to hold the part up here so it can see it really well. You tell it to look for the targets. Okay, and you can see it's found some targets. Now, What does that mean? Well, now it's going to track those targets as well as the scanning. So now let's go ahead and start our scanning, and you'll see what's going to happen. Okay? So we'll start scanning like we did last time. We're moving along, everything is great, but then all of a sudden the table gets moved or bumped, or let's say the C-track gets moved. So notice as I move this around, yet my scan data is still lined up. Okay? If I were to move the table, or sorry, move the part on the table, everything is still lined up. So no matter what movement or vibration, both to the C-track system and to the part itself, you can see we can still track the part. Our data still looks perfect. So whether we were probing or scanning, this dynamic referencing system is a great way to go. And you can see it's tracking 8 of 9 targets. If I get in the way of some of them, it still has plenty to go. So that's dynamic referencing, and we probably use it 80% of the time when we're scanning. Because, for example, if we have a really big part, like a vehicle, we can put those targets on it, acquire all those targets with the C-track, and then just move the C-track around as we need to scan the part. For smaller parts like this or shop floor metrology, same thing. We don't have to worry about movement, vibrations, things like that. We're going to hold the exact same accuracy that we've been talking about, even though our part might get moved around a little bit. So dynamic referencing is a fairly unique system and very, very important when you're trying to hold good accuracy, especially out in harsh conditions. So we've mentioned that the MetraSCAN system can do both scanning and probing. So I thought we'd demonstrate that on this transmission housing. And this is a great part because we've got some, contoured surfaces and some real complex shapes, but then we have some small holes. We have all the veins here on this side. We've got some fine features. And, probing is great for certain things as well as scanning. The organic stuff scanning is very good, but getting down into these veins and these tight features or some of these small holes, the scanner is going to have trouble getting the data down in there. And that's where probing can really be handy. And again, we have a video that goes through what applications are good for scanning and probing, and I'd invite you to watch that. But we'll go ahead and show you kind of both here. And let's start by telling it we're going to do the scanning first. And we're just going to go ahead and scan the part. Let's zoom in a little bit here on our screen. And we'll just kind of get a quick scan. Again, you can see how fast this scanner is. Okay, and get a little bit here up on the top. And maybe come around and get some of those veins a little bit. Okay, so let's stop scanning for a second, and we're going to hold to stop. And now we want to switch over to probing, okay? And whether you're doing inspection or reverse engineering, this process really doesn't change. We just come in here. In this case, we're going to tell it to probe. So whether you're using specific inspection software or the VX Element software or VX Inspect, you can go back and forth between probing and scanning at any time. So now we're in the probing mode, and for this we're just going to probe some entities. We're going to start by making a plane. So now we take our handy probe system, we put it up here, and we got to take at least 3 points. So again, as long as that C-track can see the probe here, we're good to go, okay? So if we take a look at what we just did, is we've just fit a plane on that top surface, okay? So let's do another entity. Let's go ahead and do, let's say, a cylinder. We will use the plane as a reference geometry, and we'll pick some points to create. And you can use the different extensions and angle adapters if you need them. And there we go. So let's go ahead and hit create. And you can see now we have a perfectly fitting cylinder. So let's do one last thing. Sometimes you have small holes or you have threaded holes. They're very difficult to scan. So we'll take the handy probe and put a big probe tip in there just so we can drop it down and at least get the center or the position of that hole. So again, we would just come in here, tell it point. Again, we'll reference that same plane and just come in here and grab that point, okay? So if we take a look, you can see now we've got a point right there. So now if we wanted to stop and go back to scanning, we just go back to the home page, go back to scan, tell it to scan, and we could continue scanning. So, you know, if we'd missed an area, we thought we needed more data in a certain area, we could do that. So it's really nice to be able to have that option to do both scanning and probing with the MetraSCAN system. So now let's take a look at the fidelity of the MetraSCAN Black. And I have here a turbocharger assembly. And this is a good part because I've got some deep cavities, I've got some small threaded holes, some other real fine features. I've got shiny machined aluminum on here, I've got dark stuff, dark plastic. So this will not only be good to see what kind of fidelity we can get with this new scanner, but how it does on the dark and shiny stuff. So let's go ahead and get started. And we'll hit the button to start scanning here. And you can see it's doing a great job. There's some small numbers and things etched in here. Some of the surfaces are a cast material. So this will be a good test. And again, go to that single line mode and you can see how it'll really fill in some of these areas in here going in that mode. So it's nice to be able to go back and forth, get down in there as far as you can, and then again back to the 30 line mode. So we'll just work our way around this a little bit. Now I've set the resolution right now at 0.5 millimeters, but the great thing about this scanner is you can adjust that. So it's always going to scan at the highest accuracy no matter what. It's always scanning at the highest accuracy. But you can adjust the fidelity or that mesh resolution at a later time. So as long as we take our time and scan this real well, later on we can change it from 0.5 millimeters to, let's say, 1 millimeter down to that 0.1 millimeter resolution. Because underneath it's just collecting points, and then when we're done and we hit stop scan, it's going to polygonize it into a polygon mesh. So at that point I can change that resolution. So again, as long as I do a good job filling it in, we can crank it down to that 0.1. I've got some threaded holes over here. So we'll scan this up and then we'll go ahead and take a look at the data and see how it looks.
All right, so let's go ahead and take a look at the scan data. And I thought for this we would just let the pictures do the talking as far as the detail and the resolution of the new MetraSCAN Black.
So this wraps up the video on the new MetraSCAN 3D scanning and probing system. This new Black system, just to summarize, can collect up to 1.8 million points a second. It's got a bigger scanning area, it's got higher resolution, it's got higher accuracy to some very rigorous standards in both the ISO and VDI, VDE standards. It's just all around a great system. Now, if you would like to learn more or schedule a benchmark, we can do that in person or we can do that virtually. Companies will send us their part, and we can set up just like you see here and do a live virtual demo. In the description area below is a quick link over to a form you can fill out, and we can get in touch with you and talk more about what your specific application needs or challenges are and decide on what is the next step. But that wraps up the video on the new MetraSCAN Black system.